This video is not AI generated. What you are looking at is an actively erupting Mayon volcano in the Philippines appearing to get struck by a meteor as it flashes across the sky as a bright green color. For additional proof, here's the infrared camera view the local 5 volts government camera caught of the same falling massive rock. However, despite what it might appear in this clip courtesy of the afar YouTube channel, go check them out and thank you by the way, Mayon did not actually get struck by a small asteroid or meteor. Instead, this is just a perspective trick since it's hard to quantify where objects are in the night sky without a known reference point. It to me seems like the meteor violently fragmented or more likely completely burned up at an altitude of around 45 kilometers or about 147,600 feet. Based on the likelihood that the first moment this fireball became visible probably marked when it first reached an 80-kilometer altitude in the atmosphere, I was able to approximate what I deemed to have been the meteor's most likely path, heading south-southeast at a compass degree of 156.6 degrees. Now, you might incorrectly think that the green fireball you saw was an effect of color adjustment on the nighttime web camera. However, it's not, as when I was a teenager I saw a fireball of the exact same color burn across the sky above my house. Meteor fireballs can burn up and release light as a number of colors, including but not limited to green, blue, red, orange, and sometimes even purple. These are the dominant elements that tend to cause each color. In the case of the meteor that burned up vaguely near Mayon, while the green coloration could have been caused by a high nickel concentration, I personally deem it far more likely that a high magnesium concentration was the cause. That means we might be able to actually put up a decent guess as to what the composition of the meteor that I estimate was 1.5 meters or 4.9 feet wide was and where it originated from. You see, for a meteor or asteroid to have a high magnesium concentration, specifically above 19%, it needs to have a high abundance of one or both of these two minerals, olivine and enstatite. And where do these two minerals tend to occur in abundance? We'll generally need a large differentiate asteroid in the main asteroid belt measuring more than 20 kilometers wide, forming in the mantle and crust of such an asteroid respectively. This means that iron meteorites and chondrites as a whole can be ignored, leaving the possibility of a stony iron palisade or more likely an A chondrite. While palisades represent material from the mantle core boundary of a differentiate asteroid, A chondrites are pieces of crust from a differentiate asteroid that were expelled into space by a collision. Many of these collisions occurred billions of years ago, leaving pieces of rock that still occasionally fall to Earth. Sadly, it is quite probable that no pieces of the meteor survived burning up due to its small size. Now, you might be wondering how common a fireball falling above an erupting volcano is worldwide. Surprisingly, it's more common than you might think. While a fireball can technically be seen in ideal conditions within a 1,000 kilometer radius of its fall, to get a nice high angle in its fall, it needs to occur within 250 kilometers of a spot on the ground. An estimated 5,000 fireballs occur on Earth worldwide each year, and if we account for the fact that there are currently 43 actively erupting volcanoes on land, and only include nighttime, we get the following. A high-angle fireball above an erupting volcano at night occurs somewhere in the world about once every 8.8 days. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.